Now, the session we're going to have a panel, the necessary advancements for the implementation of the CA link. We'd like to invite Professor Maria Cristina, Engineer Camilo Machado, Professor Qingmin, Professor Leiki, Professor Samorodov, and to moderate the panel, Professor Antonio Carlos Siqueira de Lima.
Well, starting again. I believe Cristina could start talking about the time of the project and the difficulties that have been found and the progress that has been achieved in this research.
I believe that with the seminar we could present the main results obtained so far for the half-wavelength study. We went a little bit further than we were thinking about in the beginning of the project in terms of studies. The protection part advanced a lot, some issues especially regarding voltages that happened during the three-phase faults. The proposal of using this gap took some time to be solved and implemented by the group. So I believe we have advanced a lot. What we would like to give to the participants is that so far we have still not identified a problem with the half-wavelength transmission that could result in some impediment for this transmission to be implemented in the world. So far we still have not identified any problem that could not be solved without even having to move forward in the electronic power technology. And the proposal for this panel here is to discuss and see where do we need to work more, what needs to be done, what are the important points that you, experts from several different fields, believe that should be analyzed, researched in more depth, and also suggestions for future projects and what the whole group recommends. Works that are being conducted abroad, in China. I know that in China you are working both with load and reconnection. In Russia, from what Professor has said, the idea is to put a half-wavelength transmission by 2020 in 1000 kV. So if we could share information and reach a point where this technology is only going to move forward if we work cooperatively, not only inside the country in Brazil, among the different institutes working with this, but also including institutions from abroad, because it's very difficult to face or to go against a technology that is well established, such as the continuous current one. So Camilo, the floor is yours. Thank you very much. Honestly, analyzing how, just reflecting on how I arrived at the seminar and how I feel now, I believe this was an extremely enjoyable moment. The amount of information that was shared here, and we were extremely happy with what is being researched from our colleagues in China and Professor Samorodov in Russia. The seminar allowed us to define several points where we can move forward in our research. Several questions about the half-wavelength technology, highlighting the study that was done in Russia with so many details that Professor Samorodov presented to us, that the test went way beyond of what we intend to do, which is a non-load energization. So they applied load, they applied faults, they could compare values that were measured to the values that were calculated. Research from Professor Lee about the secondary arc, which is one of the points that once they are solved, it will bring a lot of advancements for the half-wavelength technology, because we could conciliate a high voltage of 1000 kV to have large significant characteristic power for the transmission of large energy blocks, and having solved the connection of the single pole connection. We could also notice the list of research from our colleagues in China and Russia, where a list was shown including protection aspects. To summarize it, I believe it is important for us to register the different and several advancements, and for us to continue to interact beyond this seminar. The seminar must not end here today. This contact is very important, and we can have a lot of advancements, because we see that there are applications in Brazil for the transmission in the Amazon. So our suggestion, Cristina, is for these several advancements, these research lines, whether the fourth conductor proposed by Professor Samorodov, discussing also the protection aspects, the electronic power, the work with the load throughout the path as was presented. So society can only gain from all this work. Our expectation is to maintain and continue to interact with our colleagues. Professor Lee.
The TRV, I think this morning, somebody gave a presentation on this aspect. I think the very close fault means very close to the circuit breaker. You may call the near area fault or outlet fault. Yeah, must be considered as the very critical for the TRV. Yeah, for the circuit breaker. So should be maybe we can do some experiments. Yeah, that's the point. And also, I think for the extinction scheme for the secondary arcs, we can go with several ways. For example, with the high one possible way to extinguish the secondary arcs, and also the scheme I proposed, the parallel impedance, need to be further verified, and also as active power injection. Yeah, it means based on power electronic schemes. That's one way we can try. Yeah, this is extension scheme for the second arcs. Yeah, and also as regards how to push the half-wave transmission technology ahead, I think if it's possible, we can try to, for example, in Brazil, try a construction, a test line. The test line can may not be very long. For example, we can improve the frequency. Yeah. For example, we construct a test line. Yeah, not 50 hertz or maybe you can several hundred hertz. Then the length can be very short. Then we can try this way to test for example, to test the stability and protection schemes and the surge arrestor. Then the voltage can be high. Yeah, that's my point. And also we can to construct maybe an international research consortium. Yeah, so to include all parties here. Yeah, we can do something to exchange manpower. Yeah, to collaborate, to co-apply some international projects. Yeah, for example, maybe in Brazil, maybe in China, maybe in Russia as well. Yeah, then we can do further job on this and to push this technology ahead. Yeah. Okay, thank you. And my point. Yeah.
Professor Samorodov.
Love. Wait a minute, there is a problem. One of area of the development in the half-wave length. Okay, listening now? Are you listening now, Professor? Professor Lee, can you hear? Yeah, okay. So he's going to start again. From the beginning, he's going to start from development in the area of technology of half-wave length in our countries is such that it is possible to make a survey about the creation of one first electric transmission of this kind to meet the corresponding projects of the work. And
весь вопрос, где ее первую нужно будет создать. И теперь, если вы помните, в начале вопрос поднимался о союзе БРИК. Бразилия, Россия, Китай, да, Индия и Южная Африка. Что интересно, что все эти страны имеют протяженную территорию. И в любой из этой стране может быть создана или и имеется потребность в создании полноволновых электропередач. Поэтому в рамках БРИК нам нужно создать секцию, которую назвать полновая электропередача и ее внедрение. Может быть, это нам поможет быстрее внедрить такую технологию.
У acho que ponto
то в одной точке мы имеем что-то, как раз это был пункт.
Put here for debate, precisely having a sort of a protocol among those three countries which are here, so we could continue the project. Not only Brazil working alone, or China alone, or Russia alone, but working together. Before this remark, I had the following thing here. I think ANEL is the one to manifest itself now in Brazil. They have to make their effort together with the national system operator in Brazil to find the room for these tests to be done in the field. It was ANEL that published the call. We know times passed, 2008 to 2013-14, but I believe that studying, it will find a way for us to carry out the tests. Another thing I would like to say is that in the studies, it's verified that if you have RID, you have more confidence in the test. So I think we should, Cristina and Camilo, do the test in CEPEL. We should endeavor efforts with CEPEL to do the test there. We had that in the program, but after the meeting with the National Integrated System, we didn't move ahead, but we should move on with that. Regarding protection, it is a suggestion I have. We should get together with other manufacturers, not only Schwarz,
to include the information from the studies that were conducted, so we can bring contribution from the manufacturers to our group. Is that okay, João, Marcio, and Elson as well? So we can put this. And I believe that they would be excited to do so. Something else is that today we should continue, we should edit the book. The book is going to bring general knowledge, it's going to disclose the information, make this book available in all universities. We're not gonna, we're gonna work as hard as we can to make this available, as well as in an e-book form to facilitate the process. I have already discussed the protocol, and discontinuity is starting a project from scratch is very difficult. So my suggestion is to continue this project. I believe we still have resources in the project. We have money, funding from the companies, from CHESF, ELETRONORTE, and ENTE. They are partners of the project, but we are open for other companies who are said that all the results are public domain results. We are not going to hide them from companies that are participating. New companies can become a part of the project, so we can move forward. And now let's introduce the CA link in the system. See, Professor Cristina, let's not only do the energization. Let's think about, with this being in the system, what is the impact that the link is going to bring. This was done, but we can also be doing transient studies and work with synchronizers, transformers, synchronizers, transformers, and I believe we are not going to stop here. The group is very excited. The seminar brought us fresh air, and this is my suggestion. I believe in the following. There's nothing else we can do in terms of simulation that is not going to convince those who are still not convinced. And I believe that those who do not believe are always going to talk about there's going to be a bird flying during the test, or a tsunami happening in Asia that's going to interfere. So I believe now the point is to build a prototype line. I agree with Professor Lee that we should work with a line with a higher voltage to reduce the distance, a higher frequency to reduce the distance, and this would be the next step. I believe we have inside the R&D plans an opportunity for a calling with this purpose to investigate. Otherwise, we are always going to be stuck in the HDVC technology. And if we are stuck with one technology, this means we are going to limit the development of a country, because this is what we are discussing, the development of a country that intends to move forward and not enter the dark ages as we had in the 1980s and mid-1990s in the electric system. Regarding the test, I believe besides varying the frequencies and working with higher frequencies for a smaller wavelength, we could work with lower voltages if we have 500 kV, but work with lower voltages in a 500 line, we could cause the short circuits in a safer environment and conduct a test that is a little more detailed. We could not add load, but in terms of defects and mitigation methods, maybe this could be done. So we have to identify what is interesting to do in a first stage for field tests. The proposal is to work with this 2500 line. Is doable. In the country today, we have conditions to use these interconnections. If we reduced it, we would have to have a generator to work with higher frequencies. Perhaps this would be more complicated than using the line as it exists. What we could do is, instead of working with energization at 1 pu, we could work with lower voltages, and that would have more safety to conduct the tests. Even to add load and to play more with the system. But I think the proposal of creating a cooperation, because this technology is only going to move forward if we have cooperation between countries. Because the pressures that exist here exist in all the countries, perhaps not so much in Russia. In China, I believe the pressures are the same. Continuous current has very strong still. So if we do not have a common goal, it would be very hard to move forward. I would like to open for the audience. We still have some time. Our transportation is going to leave here at 2:45. 45 minutes. So I'm going to open for the audience. Without trying to cause a controversy here, but I would like to, I'm going to disagree about the insisting with the test, not the test in Serra da Mesa, but I believe there's a number of difficulties. For example, going to a lower voltage level. This implies in having a huge corridor, a huge geographic space available. What would be the size, the extension of the system for us to get this? The other issue is regarding the use of higher frequencies for tests. There will be a lot of critics regarding the transient damping. I believe the best way is the simulation way. It's more than proved that the performance issue in transients and regimes, I believe that the issue of the test is a secondary issue. And perhaps insisting on this issue so we can conduct a simple test on the non-load line that already exists in the system. To do this, we are having so much difficulties. Imagine the possibility of having lines available in the Brazilian system to apply faults. This is desirable, of course, but from the non-technical perspective, but from the operational perspective, it's also almost unfeasible. So I believe the best way is to continue with the simulations, verifying all the difficulties for the implementation, because in the seminar I believe they would be the issue of building the transformer with an automatic tap, or automatic or manual, but at a long range, the issue with unbalancing, the issue of detecting the fault in the middle of the line correctly, the issue of if the reduced isolation distance in practice could be used. I believe that with these little details, these small technical difficulties that still need to be studied in more depth, I believe by solving these issues and the simulations, this would be enough for the implementation of a project, a practical and real project, to open, try to enter an EPE bid in the conventional methods. I agree that we could work without the test by defining a number of studies to be done based on the simulators that we normally use for any new expansion in the system. Regarding the unbalancing transformer, this is necessary for us to reduce the losses, because once we work with this load profile, which is very variable, which is the case of our transmissions, but perhaps in the future, if the half-wavelength interconnections are used as the large corridors, this variation might not be so elevated, and perhaps we can live with the loss. If we decide to use the half-wavelength, we can live with the loss, and we need to quantify this loss with values that are not so, because we criticize the weights that are attached to the losses. With a 180-degree transformer that is going to generate the half wavelength, if we separate some generators or one substation to be the collecting substation, we wouldn't necessarily need this 180-degree transformer. We could have the correct angle and the defader. The idea of changing the reduction power, if you believe you don't need the power reduction, then you would not need this dephaser transformer. I believe we could work with things that are part of the half wavelength, intrinsic to it. So solving the secondary arc, perhaps an over voltage, how we can remove it from the quasi-resonance areas. So these are issues that are specific to the half wavelength, but I would not include the transformer in this list. But I agree that we could work with simulations more than the tests, defining a set of them, but to move forward. I would like to hear when Luiz presented the essays, which is the main, what was the main, his main motivation. I would like to hear from Professor, what was the motivation behind, the main motivation that led the technical staff from Russia to propose and conduct these tests? So what were the main gains from the test, and what was the importance for the test for the real implementation?
The motivation was simple. Many experts considered that this is something unreal and that that line is not going to be able to work. And there were many experts as such. So there was only one way to convince them that the half-wavelength system is simply highly viable. In that was the greatest objective of the tests, because all other things were solved through calculation, all the other things were solved through calculation and modeling. But in what only those experts doing the modulation really believed in it, who did the calculations. I could say that by then
I can say that at the time there were no simulators as we have today. Perhaps for today, when we introduce a case into ATP, we know that precision is going to be dependent on what we have in terms of data, but it's not going to be so different from what actually happens in the field. And perhaps at that time, the simulators that they had, the tools were not exactly the same as the ones we have today. So to convince, they had to do the tests.
that is not really true. Yeah, there were simulators, they were weak, but we at the Institute had a large electric physical model in which there was a 3,000 kilometer line. There were models for generators. We had the whole equipment that was necessary, and all those things were worked in this physical model, including we got ready for the test. But those experts who didn't believe in this technology, well, those tests, those modeling didn't convince them.
Muito obrigada.
В миллисекундах.
E super são mais dependendo dos níveis de demand new ways or new tests, because once you apply the half wavelength, if there are also, you need different ways to test the devices, surge arresters, to calculate energy, and this perhaps is going to demand special standards. But I believe this is not a problem and could be easily solved. Just a quick comment about the issue behind the tests. Some people say in the industry that the conduction of the test, non-load test, will not be a significant element to prove the feasibility of the half wavelength, because once it's non-load, you have under voltage throughout the line, so it would be essential to get the load. What I see is that the conduction of the test that was done in Russia with Professor Samorodov, he accomplished this goal. So in reality, the test here should happen in a more complete way. From our point of view, what is important is for us to have enough elements to provide and make available for the planners today in Brazil. This is done currently by EPE, so we can include this technology in the long-distance transmission. To do so, we already have enough elements in several fields related to the values of the overvoltages, requirements and circuit breakers, and generators as well, energy and surge arresters that we have solutions for. I forgot to mention important data from a presentation about the complementation of the half wavelength. So we are going to have some applications in Brazil that will not use a little bit more than half wavelength. But even like this, the technology is applicable due to compensation and, as Professor Samorodov likes to say, the tuning. Compensation or tuning. So this broadens our options for the offer of the half wavelength. So what we really need to understand, we need to put a final stop at some moment at this R&D researcher that had as a goal the non-load energization, and then start and perhaps have a cycle with a broader goal, which would be consolidating these points of protection, single pole reconnection, compensation for lines that are beyond or not reaching half wavelength, and with that effectively being able to make this technology available. And finally, something that can change the planning criterion, because what is done today? Alternative for long distance, what are the technological solutions? CA with series compensation or shunt compensation, continuous current, bipole, dual pole, and for half wavelength they use two circuits. This penalizes the half wavelength, but once that we work with ultra high voltage lines and we make it possible for the single pole reconnection, there are no longer arguments. We can use a simple circuit with a single pole reconnection to be compatible with the continuous current. Unfortunately, as the American says, time is of essence. We are behind schedule. Now I believe perhaps EPE has the purpose of doing a line with 1,000 kV somewhere in Brazil to conduct some tests. In China, they have 640 kilometers already operating at 3 years, and so far there hasn't been any defects. It's extremely reliable. 800 kV with continuous current is also extremely reliable. I believe that if we propose, since we have this idea of creating a test line of 1,000 kV in Brazil, let's do it instead of São Luís de Tapajós from, let's say, the city of Rio de Janeiro or the city of Fortaleza or any place that is going to give us the 2,600 kilometers. And then in the future, if we want to transform this line into a conventional line, you do the segmentation and include the intermediate substations. This is a proposal that I believe is doable and covers what EPE is trying to put in the future projects for Brazil. Deve ser desenvolvido. I'm from the planning secretariat. I believe understand that study. Interesting to try to understand the small applications using a line with that capacity. But when we stop to think, for sure this is not going to be done. In one way or the other, this is going to be served in a different way, but not through a line. Such a large power going to in the middle. Study, understand how it works. Important physical. So this apply the technologies. It's more difficult because we want more safety. Every time there's a blackout in the country, this generates to us a work effort with all the companies to improve substation arrangements, to create new configurations on these arrangements, and the authorization for the companies to implement this. Just for you to have an idea, we have 5 reports for studies conducted by the National System Operator, together with the Energy Ministry. 3 of them was already approved by the council that monitors the electrical system, which is the second agency in terms of decision for electrical energy, being behind only the National Council for Energy Research. And these 5 reports changed substations in the country. We have more than, if I'm not mistaken, 106 substations to have sectioning of bus bars, change of equipments, everything already established with the owner of the substation. Why did I mention the deadline of 5 years? Because all the devices are energized. So can you imagine getting authorization from the national operator to deactivate the equipment to make the substitution? So these type of improvements, they are happening. The only difficulty that I see sometimes, what I felt here is that the amount of the transmission of a halfway length is too high. If you look at the hydraulic availability that we have in the country and do an analysis, we are reaching the end of the large power plants due to environmental difficulties, indigenous, or the problems with the native people in Brazil. Perhaps in the future, when we have a political change, or when it's placed to the society the cost of not building a hydraulic plant instead of creating another type of power plant with a higher cost, and then a decision is going to be made. Yeah, his microphone is not working again. I'm sorry. Every time there is a new region that has not been explored, it's our posture when creating the project guidelines is for us to have substations to cover that location, so the locations surrounding that region. We need to see, before we had separated system, and then all the countries connected. We have 4 north-south interconnections. We have 6 or 7 lines to the northeast. All the countries interconnected, and we're closing the areas that do not have ultra-high voltage line. The case of the state of Bahia, the state of Pernambuco, the state of Espírito Santo. And this is going to happen naturally with the growth of the market. I'm going to speed up, otherwise I'm going to be out of time. All I wanted to say is that this is planned, so perhaps the amount that is being considered to be transmitted by this technology should not be such high, so reaching 8,000 megawatts, 10,000 megawatts, perhaps something in a more compatible range that you would do in 2 lines, not just 1, and this would cause less impact in the system. That's all I had to say. Thank you very much. Due to the time, I'm going to have to close the panel and the questions as well. For those of you who want to catch the bus directly to the airport, you can go on the first bus. There will be a second bus for those who want to see the RTDS. So I'd like to thank all of you for your participation. I hope this was a moment for us to move forward with this technology. And the seminar is going to make all the presentations available, and if we could maintain a work group, as Marcelo has said, the participation of R&D is a strategic project, so participation from other companies, I believe this is possible, and the R&D documents must be public domain. So, and this need to be agreed with the companies. So thank you very much for your participation. I believe this was interesting for all of us. We could take a picture, a group picture.